Very good morning to everyone. In this lecture, EC 8791 Embedded and Real-Time Systems, Department of Electronics and Communication Engineering. In previous session, we are discussing the real-time operating system and also the processing mechanisms in multitasking and multi-processing methodology, and also the multi-rating system designs, how to the scheduled the algorithm based design techniques, and also the how to memory can be shared to the CPU and also the input output device. Then how to evaluate the operating system performance and also power optimization strategies, etc. Now in this session we are going to discuss the examples of a real-time operating system. It is operating systems modules. The first one is POSIX. It's a Unix operating system. It created by the standard organization. The POSIX complaint operating system or is the source code compatible. The source code compatible, it is optimized through the energy and also the power and also the latency. So the application can be compiled and run without the modification on a new POSIX platform. It has been extended to support a real-time requirements, different applications environmentals. So in many real-time operating system are POSIX complaint, and it serves as a good model for the basic real-time operating system technology. The Linux operating system as a platform for embedded computing. So the Linux is a POSIX compliant operating system that is available as open source. The Linux was not originally designed for real-time operating operation. Some versions of Linux may exhibit long interrupt latencies. To improve the interrupt latency, a dual kernel approach uses a specialized kernel. The kernel for real-time process and also the standard kernel for non-real-time process. For the example of a new process is created by making a copy of existing process. The copying process creates the two different processes both running the same code. It is a complex task. It is to ensure that one process runs the code intended for new process while the other communication continue the work of the old process. Next one is a scheduling in the PO6 operating system. Here the scheduling in PO6 operations, the process makes a copy of itself. We are calling the fork functions for k of functions. That functions causes the operating system to create a new process that is a child process, which is nearly exact copy of the process that called the for k of the parent process. They both share the same code and the same data values with one expressions. The written values are for k. So the parent process is returned the parent ID number of the child process, while the child process get a written value of 0. We can therefore test the written values of for key of value to determine the which the process is child ID is equal to for of k. So we can understand if child ID is equal to 0, it is a must of the child. So the conditions of child condition, that is a child ID is equal to 1 or 0. So the functions take an argument, the name of the file that hold the child code and array of argument. The process with a new code and start existing from the main functions. In the absence of error, should never return the code for the code that follows the call to prior and exist take care of the case of failed or return to the parent process. So the child ID is 4 4k. Yeah. If child ID is equal to 0, must the execution process is a mild child or child arrangement or priority execution. This exist of 1. So the wait functions not only return the child process status in many implementation of the POSIX, they may ensure that the child ensure the parent functions perform work of the parent functions. So these POSIX process run into own address space and also it cannot directly access the data or code. So we can allocating the real-time scheduling in POSIX. The POSIX support a real-time scheduling in the POSIX priority scheduling resources. What is the scheduling resources? We are supporting the rate of monotonic scheduling in the scheduled in first out scheduling policy. It is a priority based scheduling scheme. It which a process run until it is a preemptive or terminates. The team of the first in first out simply refer the process run in first come and first service order. So the POSIX support and also a direct shared mechanism, memory mechanism, and it is supported the counting in the options or operatings. Accounting as allows more than the one process access to resources at a time. So the parent process uses the pipeline function to create the pipe to talk a child. Each end of the pipe appear to the program as a file. So the pipe function is returned as array of file descriptor, the first for the write end, the second for the read end. POSIX allows support message request under the POSIX message passing the facilities. So we can using the Windows CE method. So these are the Windows CE mechanism. It is designed to run a multiple hardware platform and instruction set architectures. So what type of application we are executed and embedded seal and remote connectivity to the other network operating system. We are using the kernel operating library in the different hardware embedded systems. So the application run under the sail and it is used the interface. The Win32 API message manage the access to the operating system and it is a adaptation layer. It provides the interface to the hardware and also the software architecture. So it provides the service such as a real-time clock, power management, interrupts, and debugging interfacing. So a board support the package for particular hardware platform include the OL or the drive. So the memory spaces. So the memory space it is support for virtual memory with a flat of 32-bit virtual address spaces. It can be statistically mapped into the memory main memory for kernel mode code, and address can also be dynamically mapped, which is used for all user mode and some kernel mode code. The flash as a magnetic disk can be used as a backing state. So the kernel space and user space, the top 1 GB is reserved for system elements such as DLL, memory mapped files and shared memory heap. The bottom of 1 GB hold the user elements such as code, data, stack and also the heap. So we are using address space in the Windows CE technique. The thread are defined executed file while reviewing the defined dynamically linked to the library, that is a DLL. So the process can be multiple thread. The thread is defined in different process run in different execution environment. The thread are scheduled directly by the operating system. It may be launched by a process or device driver. So the device driver may be loaded into the operating system or process. It creates the thread to handle the interrupt, and the thread is assigned an integer priority. That is a integer priority 0 is a higher priority, and also 255 is a lower priority. So the priority of 248 through 255 are used non-real thread. So the operating system maintains a queue of ready process at each priority level. This is a execution of the thread can also be blocked by higher priority thread. So the task may schedule the user either of two policies. That is a thread run until the end of its quantum, or thread run until the higher priority thread is ready to run. Within each priority level, round robin scheduling is used. That is not for priority based scheduling. So the Windows CE support the priority inheritance, which when priorities become the inverted, the kernel temporarily boost the priority of the lowest priority thread to ensure that it complete and it release the resources. The kernel will apply the priority inherent to only one level. If a thread that's suffer from priority inversion in turn cases a priority inversion for another thread. The kernel will not apply priority inheritance to solve the next priority inversion. So in this lecture, we have to discuss the examples of operating system in real-time operating in embedded design technology. Thank you for watching this video.